Hi, in this video we're gonna see how we're gonna build a circuit and how we are gonna use the multimeter to get the results from the circuit that we're gonna build. First, we're gonna build the circuit and power up the ICs. As you can see here, I already built the circuit. The only difference is I used DB switch number 1 and 4, and then I power them correctly. Next, we're gonna talk about what circuit we wanna build, because we know, like the previous circuit, it was just to get the switch ready, get the inputs X and Y, and also get the resistor in place and power them. So right now we're gonna have X and X naught. Also we're gonna have both X and Y. So this is the second gate that we're gonna build. And the third one, we're gonna have X or Y, as we can see here. Now, since we have the circuit, let's see how we apply it to the board. So the first thing I'm gonna use, let's assume that pin number 1 is gonna represent X for the entire of this experiment. So I have here pin X. Next, I need to decide where is the inverter. So I go to the datasheet if I forgot, and then decide that 04 is the inverter. So I go to the datasheet also of this exact IC after I determine it, to check where is the inputs and the outputs and pick a gate. Here I'm gonna use the second one, so pin 3 is an input, pin 4 gonna be the output. So that needs to connect to pin number 3. Came here and then I count them. So here pin number 1 is pin number 1, 2, so it needs to go to 3. Now which this goes to pin number 3, I have pin number 4 if I want to read X naught, which is the output. Now I'm gonna continue plugging X. So rather than taking X from the switch to the second gate, which is the AND gate, I'm gonna take it from the same column, hence we know that the entire column is connected. So I'm gonna take it from this point, and it's gonna stay X, and then decide where is the inputs for the next gate. For this one, I'm gonna use the first one, so pin number 1 and pin number 2 is the inputs. So I'm gonna stick it to pin number 1. Here we go. And last, I'm gonna take it from the same point to the third gate we're gonna use, and for example, let's use the second OR gate. So pin number 4 and pin number 5 is the inputs. So this one needs to go to pin number 4. Here we go. This is pin number 4. So now I have all of X, 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 and X. Okay, now we need Y. So hence we know, like, Y is on DB switch number 4. We're gonna take from that point, and here we go. We're not gonna use Y naught, so we're gonna jump to the second IC, and then we're gonna use pin number 2, hence it's the second input. Same thing we do for Y. So we take it to pin number 5 on the OR gate. Now we have the circuit ready. We're gonna use the multimeter and the power supply to get the results. Now, here we go. With the power supply, I'm gonna use output 3, because all what I need is 5 volt, and this output is giving me 5 volt fixed. If you don't know how to use this device, which is the power supply, or this device, the multimeter, I would recommend watch the previous videos about the introduction about these devices. Quick summary, I'm gonna use the positive for the positive, the negative for the negative. I'm gonna power the device here, and then I'm gonna power the output 3, just the output 3. As you can see here, there is the 5 volt on the screen, so the device is powered on. Next, I'm gonna power the multimeter. take the ground, stick it to the negative. So this is the negative. I'm gonna stick it to the negative of the power supply. Next, I'm gonna use the positive from the multimeter. As you can see, we have 5 volts, so we are receiving power from the DC power supply. Also, we can check the VCC on each IC, which is pin number 14, if you don't remember. So this is 5 volt, and this is 5 volt also for the AND gate, and this is 5 volt for the inverter. So next, as you can see here, it is on the open side. All the switches are pressed to the open side. So what does that mean? If we come here, we're gonna see the voltage, it's 178 millivolt. So there is no connection between the upper part and the lower part. Same for the dip switch number 4. As you can see here, there is a difference because of the noise. So now this is X, as you can see, which is pin number 3. So if I want to read the output of X, which is pin number 4, as you can see, 4.2. What does that mean? So I come here to the table, and then it told me when X is 0, so X is pin number 3, remember, the output voltage, and 0 means open, the output voltage should be on pin number 4. We need to write here the 4.2 volt, and for the logic level, it's going to be high. Next, what does it mean to have 1? So we're going to put the output the same, but we're going to press the switch to make it 1 or on. Here we go. So right now we have 141 millivolt. We need to write that on the table. And in the same way, we're going to get the results for the OR gate and the AND gate. Let's take the positive of the multimeter to read another output. Now we go to the table and check the other gate that we need to get the results is the AND gate. Remember to use the switch to control the X and Y. We're going to put whatever voltage we're going to get from the multimeter into this section. Now we go to the AND gate. We see which pins we used, pin number 1 and 2. So the output goes to pin number 3. If you forgot, you just need to look to the inputs and then go to the data sheet, determine what is the output. Next, you go to the multimeter, change the switches to the proper positions. Remember 0 mean on, 1 mean off. Same thing for the OR gate. And in that way, you would be able to fill the table. For the OR gate, we use pin number 4 and 5. So the output gonna be on pin number 6. As you can see here, I plug it to pin number 6. Then same way, you go to the switches, change them to the proper positions, and then you're gonna get the results and fill the table. Thank you so much for watching, guys. I hope that you enjoyed the video. Thank you.